This is lesson 2-4 of the distributive property. The distributive property says for every real number a, b, and c, a times the quantity b plus c equals a times b plus a times c. A times the quantity b minus c equals a times b minus a times c. Likewise, the quantity b plus c times a is ba plus ca, and the quantity b minus c times a is ba minus ca. The reason for that is we distribute the number on the outside, the number we're multiplying, to the numbers inside the parentheses. And when we distribute them, we multiply. So a times b gives us the a times b, plus a times c, a times c. Same thing down here, a times b, minus a times c, ac. And it's the same over here, except kind of backwards. So we're still distributing the a to the things inside, but in a different order. So we do b times a, which is ba, plus c times a, which is ca. b times a, minus c times a, ca. So we're distributing the number on the outside of the parentheses times the numbers inside the parentheses. Here are some examples with real numbers. 5 times the quantity 20 plus 6 is 5 times 20 plus 5 times 6. So most of you would say, well, why don't we just use PEMDAS? And you can. 20 plus 6 is 26, and then you would do 26 times 5. 5 times 6 is 30. 5 times 2 is 10 plus 3 is 13, so that's 130. But if you use the distributive property, it's much easier, and you don't need to go off to the side and multiply. 5 times 20 is 100. 5 times 6 is 30. 130, there's your answer. It's the same thing. 9 times 30 minus 2. 9 times 30 is 9 times 30 minus 9 times 2. We distribute the 9 to the numbers inside the parentheses. So yeah, you could go off to the side. 30 minus 2 is 28. And you could do 28 times 9, and you could work this out. Or 9 times 30 is 270 minus 9 times 2 is 18. 270 minus 18. 270 minus 10 is 260, minus 8 more, 252, and there's your answer. A couple more. We'll do some like these where they're on in the back end. 20 plus 6 times 5, and 30 minus 2 times 9. So notice, same numbers, it's just the 5 now is in the back instead of in the front. So we do the same thing. 20 times 5 plus 6 times 5. We still multiply both our numbers inside times the number on the outside. 30 times 9 minus 2 times 9. Then it's the same answers. Let's look at some other examples. Example 1, simplifying a numerical expression using the distributive property to simplify. So yeah, we could go off to the side, we could do 98 times 26. We all know how to multiply like that. But there's an easier way. Let's rewrite 98. So I'm going to do 26 times, instead of 98, I'm going to rewrite it as 100 minus 2. That's still 98, but it's going to be easier to multiply. Some people would say, well, why not just 90 plus 8? But doing 26 times 90 is still pretty challenging. 26 times 100, though, 26 times 100 minus 26. Let me go ahead and draw our line. 26 times 2. 26 times 100 is very simple. 26 times 100 is 2600. 26 times 90, not so simple. Minus 26 times 2, 20 and 20 is 40, 6 and 6 is 12, 40 plus 12 is 52. And then we just do 2600 minus 52, and we get 2548, which you would have gotten this way too. This way is much easier to do. Let's try a few more. Again, you want to rewrite it. So 13 times the quantity. Instead of 103, 100 plus 3. And then distribute. 13 times 100 plus 13 times 3. And then simplify. 13 times 100, 1300 plus 13 times 3, 39. So 1,339. On the next one, again, rewrite it. 21 times, instead of 101, we'll do 100 plus 1, and then distribute. 21 times 100 plus 21 times 1. And simplify. 21 times 100, 2100 plus 21 times 1, 21. So 21, 21. C, again, we'll rewrite it. 24 times, and we could do 90 plus 8, but 90 is still kind of difficult, so we'll do 100 minus 2. And then distribute. 24 times 100. And 24 times, or minus 24 times 2. 2,400 minus 48. And then simplify. 2352. Finally, 15 times the quantity, 100 minus 1. 15 times 100 minus 15 times 1. So we get 15 times 100, 1,500, minus 15, we end up with 1485. Now, once you get good at the distributive property, you can start skipping this step altogether. You can do that in your head. 15 times 100, 1,500, 15 times 1, 15. And you can start skipping that step. Excuse me. Example 2. Find the total cost of 4 CDs that cost $12.99 each. So the each tells us we're multiplying these together. So I have 4 times $12.99. Well, we're going to use the distributive property again, so let's rewrite it as 4 times, instead of $12.99, that's really close to $13, we'll do $13 minus 1 cent, and that would give us $12.99. And now we can just distribute. 4 times 13. Again, you can start skipping this step if you're ready, and 4 times 1 cent, so minus 4 times 1 cent. 4 times 13, 13 plus 13 is 26, 26 and 26 is 52, minus 4 times 1 cent, well now you have 4 cents, so we have $52 minus 4 cents, or $51.96. Much easier that way. Let's look at one more. Find the total cost of 6 pairs of socks that are $2.95 per pair. So again, we're multiplying. 6 times $2.95. And we want to rewrite it to use the distributive property. So 6 times the quantity, $3 minus 5 cents. And then distribute. 6 times 3 is 18. There's that step I was talking about skipping. And then 6 times 5 cents would be 30 cents. So minus 30 cents. Leaves you with $17.70. Example 3, simplifying an expression. So we can't really solve it. All we can do is simplify. So we're going to distribute. 3 times 4m, 3 times 4m, minus 3 times 7. Again, you can start skipping this step if you're ready. So 3 times 4m, that's 12m. 3 times 4 is 12, tack on that m, minus 3 times 7 is 21. And we can't actually subtract these. These are not like terms. You can think of this like 12 apples minus $21. You can't subtract 12 apples and $21, so there's nothing else we could do. It's in simplest form. Let's try a couple more. Again, we're distributing. 2 times 3. 2 times 3 is 6, and 2 times, minus 2 times 7t is 14t. And we can't subtract 6 minus 14t, so we're finished with that one. On B, here's some of those were the numbers behind. So 4/10 times 3 plus 1 1/10 C times 3. 4/10 times 3 is 1 2/10. 4 times 3 is 12. There's one number behind the decimal. Plus 3 times 1 1/10 is 3 3/10 C. And again, not like terms, so we can't do anything else with them. Example 4. Using the multiplication property of -1. Remember that when you multiply -1 times a number, it just gives you the opposite of that number. -1 times a positive 5 is a -5. -1 times a -1 times a -5 is a positive 5. So really all it does is just change the sign of your number. So that's what we're doing. In math, we like to leave out ones everywhere. So there's really this imaginary little 1 right here. So it's -1 times 5q and -1 times 6. So -1 times 5q minus, it's that minus there, -1 times 6. And then we simplify. -1 times 5q is -5q minus -1 times 6 is -6. And we can simplify this. Instead of minus a negative, you know it's the same as adding a positive, so -5q plus 6. That's one way to do it. Or you could work it this way. This is -1 times 5q is still -5q. -1 times, and you can, this is also a -6. It can be thought of as a -6, or you can think of it as -6. So either way, -1 times -6 is a positive 6. So notice, either way, you get the same thing. So you can treat it as a negative, multiply -1 times -6, or you can treat it as a minus, a subtraction sign, but you'll still get the same answer. It's the same thing on these. If we treat this like a negative sign, so 2 times 3 is 6, 2 times -4t is, or -7t is -14t, so that's where we get the -14t. Okay, let's look at a couple more. Again, there's that imaginary 1 out front. -1 times 2x is a -2x. -1 times 1 is -1. And one more of those. 3 times -1 is -3. -8a times -1, a negative times a negative, is a positive 8a. So notice all we're doing when we multiply by a -1 is changing all the signs. Was positive 2x, now it's negative. Was a positive 1, now it's negative. Down here, it was a positive 3, now it's negative. It was a negative 8a, now it's a positive 8a. So when you multiply by a -1, all you're doing is just changing all the signs. All right, let's look at some vocabulary. A term is a number, a variable, or the product of a number and one or more variables. Before we write all this, I want to go ahead and give you an example to compare it to. So let's say we have 6x squared minus 5xy plus 3y minus 12. So the terms would be all of these. 6x squared is a term, 5xy is a term, 3y is a term, 12 is a term. They're a number, 12, a variable, or the product of a number and one or more variables. This is the product of a number and a couple of variables, the product of a number and a couple of variables, the product of a number and a variable. Those are all terms. A constant is a term that has no variable. So 12 is the only constant in this expression. It's the only term without that just is a number that doesn't have a variable. Coefficient, a numerical factor of a term. So the coefficients here would be 6, 5, and 3. Those are all coefficients. And then like terms have exactly the same variable factors. So here we don't have any like terms. None of these terms have the exact same variable factors. So let's look at some like terms and non-like terms. (3x) and (-2x) are like terms. They both have an x as their variable factor. (-5x squared and 9x squared are like terms because they both have x squared as their variable factor. xy and (-xy) are like terms because they both have xy as their variable factors. (-7x squared y cubed and 15x squared y cubed are like terms. They both have x squared y cubed as their variable factor. Not like terms. 8x and 7y are not alike. One has x, one has y. 5y and 2y squared are not like terms. One has y, one has y squared. 4y and 5xy. One's just a y, one's xy. X squared y and xy squared. One's x squared y, one's xy squared. Example 5, combining like terms. So like terms, again, remember they have the exact same variable factors. So look, w squared and w squared, they have the exact same variable factors. Therefore, they are like terms. Again, remember, we like to leave out 1 everywhere. So there's this imaginary 1 in front of w squared. There's a w squared. There's just one w squared factor. So negative 2w squared plus 1w squared. Negative 2 plus 1 is negative 1 w squared. And then we can simplify that. Remember, we leave out the 1, so get rid of the 1. So it's just negative w squared. A few more. 7y plus 6y, they are like terms. 7 plus 6 is 13. 7y plus 6y is 13y. 3t's minus a t. So if I take away 1t, then I have 2t's left. Remember that imaginary 1. Negative 9w cubed minus 3w cubed. So here's where we have to use our adding the opposite rule. Now they have the same signs and we add. Negative 9 plus negative 3 is negative 12. They're both w cubed. 8d plus c is 9c. Okay, last example. Real simple. All we're learning here is that the quantity means everything following this word is in parentheses. That's it. So we're just learning something else for writing our expressions. Product, means multiply. So we're multiplying negative 6 times 7 minus m. So negative 6 times the quantity 7 minus m. And that's it. Do 2 more. Negative 2 times the quantity. So everything after that word goes in parentheses. T plus 7. So negative 2 times t plus 7. Last one, the product of 14 and, so remember product goes where the and is, so we're multiplying there. The quantity, a plus w. So everything after quantity goes in parentheses. 14 times the quantity, a plus w. And that's it for this lesson on the distributive property. Good luck.